Hey mathematicians, here are your notes for 7.3. We're going to be using something called elimination today. So remember in 7.1 we used graphing, yesterday in 7.2 we used substitution, and maybe you just thought the whole time, hey, these methods aren't for me. That's okay. That is why math is awesome. There are a ton of different ways to get the same answer, and you get to pick whichever one you like the most. So, quick bell work. Let's review because we should be well-rounded individuals that know how to use all of the tools in our tool belt. If I give you this one, solve the following system using substitution. We've got x plus y equals 16 and x minus y equals 8. Go ahead and give that one a go, try it on your own, and then come on back and we'll do it together. All right, let's take a look at this one. If we remember our solve by substitution steps yesterday, our first step is going to be solve for a variable. I'm going to go ahead and solve this one right here for y. I'm just going to move that x to the other side. So I get y equals negative x, moved it, negative, plus 16. Our second step was substituting into the second equation. Make sure you don't substitute it into the same equation. That kind of defeats the purpose. So I'm going to substitute it in right here for my y variable. So x minus y, but remember I like to put it in parentheses to remind myself that I have to distribute. So x minus negative x plus 16 equals 8. And then we're going to solve for that variable. Negative x makes this positive, so x plus x is going to be 2x. Negative here would be negative 16, so 2x minus 16 equals 8. Move that 16 over. We're going to go ahead, and get 24. And of course, x equals 12 when I divide both sides by 2. Remember then, our third step is to substitute that variable back into either of our equations. Now it doesn't matter because this is going to work for both of them. And solve for the other variable. So let's just go ahead and plug it into the first one. X plus y is 16. If I know x is 12, well then I'm going to put 12 in for x. So 12 plus y equals 16. Subtract that 12, it's a positive here, so I have to subtract. 16 minus 12 is 4. And then, of course, final answer, we put everything back together in a neat little package and make it 12, 4 for our coordinate point. That is your substitution review. So today's goal is to be able to solve a system of equations by using elimination. Now there are two parts to this. We're going to look at it more tomorrow, but today we're going to be using addition and subtraction specifically. As usual, let's get those brains working on a real-world problem right off the bat. Two companies charge a flat fee of $20 to repair a cracked phone screen. One company charges $5 per hour for the repair, and the second company charges $4.50. Which company to use? All right, so y is going to be the cost of repair. X is going to be the number of hours to repair. We don't know how long it's going to take. Maybe it's an iPhone. It's going to take a couple days. Ooh, just kidding. I love Androids and iPhones equally. Just kidding. Okay, anyway, so one company charges $5 per hour. So we're going to say company A, their cost to repair is going to be equal to that $20 flat charge, $5 per hour. 5 per is the same thing as 5 times $5 per hour plus that $20 flat fee. All right, not too shabby. Company B, the price is going to be equal to $4.50 per hour. Okay, instead of charging 5 times x, we're going to do $4.50 times x, but they've still got that $20 flat fee. So which company to use? Oh my gosh, Miss Burry, why would you even ask me that? Obviously, if they charge the same amount, but one is cheaper per hour, I'm going to go with that one. All right, so the obvious answer to that question is the second company. But what about when the answer is less obvious? So one of these maybe charges a different amount per hour. I'm sorry, not a different amount per hour, a different flat fee. So in that case, we're going to have different setup matching coefficients. And this is where the method of elimination comes in handy. So we're going to write the steps here, label the steps on our problem. So we're going to first start by lining up our variables, okay? We got to get these in order. And I really like standard form where we've got our ax plus by is on one side and it equals c on the other. This is just the easiest way to set this up. Second, we're either going to add or subtract down. And you're like, well, which one is it, Miss Bury? Well, we're going to treat this like a giant addition problem. Remember when you used to line it up 3 on top, 2 on bottom, you just add down? We're going to do the same thing here. So we're going to eliminate using addition in this first one. So I'm going to put a little addition symbol over here, right? So I'm going to add down. 2x plus 3x is 5x. Positive 3y minus 3y, when I add those two, is going to be 0. Okay, looks like I eliminated a variable. And then 12 plus 3 is 15. Well, this worked out really nicely because now I've got 5x plus 0 equals 15, and I can pretty quickly see that that 0 doesn't change anything. And if I divide both sides by 5, I get x equals 3. Now that I've eliminated a variable, I'm going to use the same process I did for substitution. Substitute value, and I'm just going to say back in because we know what that means as far as substitution. So if x equals 3, I can plug it into either of these equations and solve for my other variable. Solve for the OV, other variable. I'm going to go ahead and plug it into this first one. So if x is equal to 3, I can go ahead and say x isn't x anymore, it's 3. So plus 3y equals 12. Takes a little bit of doing. That's 6. I'm going to move the 6 to the other side. These are being added, so I'm going to subtract it. So I get 3y equals positive 6. Dividing both sides by 3 gets me y equals 2. And just as I did when I was doing substitution, I do want to put my answer back in a neat little package as a coordinate pair. Just like that. But what about elimination using subtraction? Well, let's go ahead and take a look at this one. In this one, I'm going to go ahead and subtract them. And you may already see why this is the case. Before, when we were adding, something eliminated. This time I need something to eliminate as well. So I'm going to go ahead and subtract down. 4a minus 6a is negative 2a. 2b minus 2b plus 0. And 16 minus 28 is going to be, excuse me, it would be negative 12, I believe. Even Miss Bury's mental math is a little bit of a struggle sometimes, but that's okay. And just like the one before, we've got that plus 0, which doesn't change anything. So I notice I've got negative 2a equals negative 12. I can just divide both sides by negative 2 and get a equals 6. And same thing that I did with the last one. Once I've added or subtracted and I've eliminated a variable here, I can just plug it into either equation to solve for the one I don't have. And just to prove that it doesn't matter which equation you put it into, I'm going to go ahead and choose that second one. So 6 times 6 plus 2b equals 28. I get 36 plus 2b equals 28. I'm going to move the farthest number away first, so that 36 is going to be subtracted to the other side. I get 2b, oof, here comes Miss Bury's mental math skills again. It would be negative 12. Did I do that right? Give me a second just to check myself. It would not. Miss Bury, what are you doing? This would actually be negative 8. That's why you gotta check Miss Bury at all times. She makes mistakes too, and that's okay. We learn from our mistakes. So 2b equals negative 8. We're going to divide both sides by 2. B equals -4. Put it in a neat little package. Check your answer by plugging both back in if you feel like it. But 6 and -4 is my answer. So, addition and subtraction are not created equal when you're using the elimination method. So when do we use addition? Well, we use addition when we line our variables up and we see that the signs are opposite. So signs are opposite. This is why we have to line them up, because we can't necessarily see that if they're not. So for example, that would be example 1, where we've got the plus 3y and the minus 3y, because when we add those, they're going to eliminate. Now, when do we use subtraction? Well, that's when the signs are the same. So in our second example, we've got 2b and 2b. We're going to need to subtract those in order to equal 0. So that's going to be when we use subtraction versus addition. Be careful with this, because tomorrow when we learn multiplication, we're going to be able to use both of these methods, but we have to be really careful that when we're using subtraction, we subtract all 3 terms: first term, second term, and third term. We don't just give that subtraction to the one that we want to eliminate, we give it to all 3 variables in the equation. All right, quick thought challenge before we go. Let's see if you can set this equation up. So 5 times a number added to another number is 17. The first number plus 2 times the other number is 7. Find the other numbers. All right, first question, can you set these up? Can you give me 2 equations? Go ahead and try that right off the bat. All right. So for me, I go ahead and identify what numbers or what variables I'm going to use, because I don't know what those numbers are yet. So 5 times a number, 5 times a number, added to another number, is, remember, is means equals, is 17. First equation, rock on. The first number, okay, remember that was x, plus 2 times the other number. So x plus 2 times that other number, which was y, is, there's another equal sign, 7. So those are my 2 equations. Now let's just take a look at this. I've given you 3 methods so far to solve this, and it doesn't say which method you have to use. So let's go ahead and use a little pattern solving ability. Which one of our methods is going to be easiest? All right, right off the bat, big numbers don't tell me to graph. Those tell me that I have to have a really tall y-intercept, and I don't like that. Substitution, I usually use if there's a variable that's really easy to solve for. And then just because we can look at it here, elimination is usually when they have 2 that are the exact same with different signs. So notice I have a 3y, 3y, 2b, 2b. It doesn't matter what the signs are. I notice here I don't have any matching coefficients, so elimination wouldn't really help me here, especially since they're already lined up. So I'm going to go ahead and have to use substitution on this one. I can either solve this top one for y, or I can solve the bottom one for x, because when you have no coefficient, it's a little bit easier to solve. I'm going to go ahead and solve this one for x, just because it's got smaller numbers and I like that. So x is equal to, move that over, negative 2y plus 7. And I'm going to go ahead and substitute that in for the first equation's x. So if x is equal to all of that stuff, let's throw it in parentheses and plug it in. So 5x and x, negative 2y plus 7, and then the rest stays, so plus y equals 17. Now let's solve for that y variable. Notice, no more x's, that's a good thing. Negative 10y plus 35 plus y equals 17. Remember, we got to combine those like terms. So I'm going to move that 35 over. I subtract that over. That's negative 18. So I got rid of the 35. That's gone now. And then I've got negative 10y plus 1y. So negative 10 plus 1 when I combine those is negative 9y. Negative 9y. All right, divide both sides by negative 9. I've got y equals 2. Just bringing my math up here if you're following along. And then, of course, once we have that, we get to plug it in wherever we want to. This one, I don't have to multiply it by anything, so let's plug it in there. Let's do the easy route. So 5x, y is equal to 2. That tells me I can plug 2 in for y, equals 17. And solve. 5x equals, minus that over, it's positive, so subtract 2 is 15. Divide both sides by 5. I get 3. Don't forget to put them in a nice, neat little package. Bring them together because they're best friends. 3 and 2. And I can always check those out by plugging them in here. All right, if you have any questions on elimination day 1 using addition and subtraction, don't hesitate to let me know.